Hello students, today we will be solving a question from the chapter number system. The question says, find the decimal expansion of 10 by 3, 7 by 8, 1 by 7. So first we'll do the decimal expansion for 10 by 3. I really hope that you know the basic decimal expansion, that is the basic division. So we'll be simply dividing 10 by 3. So we know that 3 3s is 9, and then by subtracting you get 1 in the remainder. Now 1 cannot be divided by 3, so we'll use a decimal point, and because of the decimal point a 0 gets added in front of 1, so you get 10 again. So 3 3s are 9. Again in the remainder we get 1. Using the decimal point I've added 0 directly. Now again 3 3s are is 9. You again get 1. Again 3 3s are is 9. You again get 1. So this process carries on itself. So you are seeing, you observe the answer which we are getting, it is 3.33 and the remainder is again and again becoming 1. So what is basically happening? So this is the situation what we call as non-terminating recurring. Recurring stands for repeating and non-terminating means never ending. So you can observe that continuously we are getting 1 1 1 1 1 only. So it's a never ending process, and in the answer the value 3 is repeating itself, and therefore 10 by 3 is a non-terminating recurring decimal expansion. And you can represent the answer 3.3 bar. So bar is used on the numbers which are repeating after the decimal points. So you can write the conclusion as divisor is 3 and remainders are 1 1 1, and put dots in front of it, represented with a dot. So now we'll divide 7 by 8, writing 8 in the divisor and dividing 7 by 8. So you cannot directly divide 7 by 8, you need to use a decimal point before. So I am adding a decimal point, and because of the decimal point now I can add 0 in front of 7. So we all know that 8 8s is 64, and subtracting it you get 6 in the remainder, and because of the decimal point I have directly added 0 in front of 6. So now 8 7s is 56, and you get 4 in the remainder. Because of the decimal point, add 0 in front of 4. And what is the number, as in does 40 lie in the multiplication table of 8 or not? So yes, 8 5s is 40. And with this you get 0 as the remainder. So what is happening here? At this point where you obtain 0, the decimal expansion terminates itself, and therefore it is of the type terminating decimal expansion. And write the conclusion. Divisor is 8. Remainders which you obtained was 6, 4 and 0 at the end. Now we'll be writing for 1 by 7. So again writing 7 in the divisor, dividing 1. It's a lengthy process, okay? This expansion is lengthy one. So 1 cannot be directly divided with 7. Again we have to use a decimal point. Because of the decimal point, add 0 in front of 1. And then you can divide 10 easily by 7. So what is the number in 10th table which is less than 10? It is 7 ones are 7 itself. So then you get 3 in the remainder. Use decimal point, add 0 in front of 3. And then what is the number which is less than 30? It's 7 4s are 28. What you obtained? 2 in the remainder. Use 0. Again, 7 2s are 14. 14 is less than 20 because 7 3s is 21. 21 is greater than 20. So you get 14. Subtract 14 from 20. The remainder is 6. Decimal point ka use decimal point and add 0. Then number less than 60. It's 7 8s are 56. Subtract, you get 4 in the remainder. Add 0 in front of 4. Then 7 5s is 35. 35 is less than 40. So you get 35. Then in the remainder you obtain 5. 5 and 0 added in front of it. So now number less than 50. What it is? It is 7 7s are 49. And observe the remainder carefully. The remainder again comes back to 1. So again you will continue with the same process. 1 add 0 in front of it, then again 7 ones are 7, you get 3 in the remainder. So this process is continuing itself. The numbers will be repeating again and again. So again This type of decimal expansion is so just read this. We get the repeating block of 142857 in the quotient. So what is actually happening? The answer is obviously 0.142857 bar, because 142857 bar, this complete unit, this complete block of numbers is repeating itself again and again. And therefore, it's a non-terminating recurring decimal expansion. Recurring because a block in the quotient is repeating itself. So now you can conclude the divisor was 7 and the remainders which we obtained were 3, 2, 6, 4, 5, 1 and so on. The dots represent that it's a never ending process and therefore we write dots. So I hope that this video was helpful for all of you. Thank you for watching.